In this video, we're going to talk about many different theorems dealing with parallel lines, transversals, and angles. So as you can see, we have 7 different theorems that will apply to the problems that we will need to solve. So let's talk about each individual theorem before we touch on the practice of that. So the first one that you see is the alternate interior angles theorem. And notice that all these theorems, most of them make sense only when there's parallelism of lines L and M involved. So in other words, L is parallel to M. So these two lines, L and M, are parallel. And this line that crosses these two parallel lines is called a transversal. Okay, this line here. So most of these theorems will depend on parallelism between L and M. So the first one, alternate interior angles. The way to recognize them is to notice that this pair will consist of angles that are on opposite sides of the transversal. So in other words, this is a transversal and the two angles in question will be on the opposite side, okay, of these transversals. So in other words, 7 and 5 cannot be alternate interior angles, 3 and 5 cannot be, 1 and 3 cannot be, right? That's already one way that you can differentiate. It cannot be on the same side, right? One of the angles will be on this side and the other angle will be on that side, the opposite side of that, right? So on opposite sides of the transversal, so you might say, but where are they? There are so many different angles that you can pair a given angle with. Well, here it is. It says both inside, okay? Both inside. So what does inside mean? Inside means that they will not go beyond the parallel lines. So in other words, if 5 is an angle, the alternate interior angle with the 5 will be 4. Okay? It will be 4. And notice that it's not next to it. It's very important that you tell the difference. It's not going to be next to 5. So 5 and 6 are not alternate interior angles. Alternate obviously means that it's going to be on the opposite sides. That's why it's called alternate, right? The sides are alternating, this side, that side, this side, that side, right? But also, they're both inside, meaning that 3 does not go beyond line L, and 6 does not go beyond M, line M, right? So 3 and 6 are alternate interior angles, or 5 and 4 are alternate interior angles. Notice that 5 is on the left side, 4 is on the right side. And when you talk about 3 and 6, 3 is on the left side, 6 is on the right side. And they're not next to each other, right? They're not next to each other like 5 and 6 are or 3 and 4 are. 3 and 6 are not next to each other. However, they're on the opposite sides and they're inside, right? Inside, because they're not going outside the line L and line M, these two parallel lines, right? So they're kind of squashed in by the parallel lines L and M. They're inside, they're here. So now let's talk about the next one, alternate exterior. So judging by the name, you can tell that definitely alternate means that they will be on different sides of the transversal, but also they will be exterior, right? So they will not be inside anymore like it was for the interior angles. Right, so they will be on different sides, but they will be outside of these two parallel lines. So that means 1, for example, must be paired with 8. Okay? Now also keep in mind that alternate interior angles are congruent. I forgot to notice mention that. So 3 and 6 are congruent, 5 and 4 are congruent. Okay, so in the same way, alternate exterior angles will be congruent as well, right? So they will be outside, on the opposite sides of the transversal, and they will be congruent. So 1 and 8 are congruent, 2 and 7 are congruent, and they're on the opposite sides of the transversal. 2 and 7, 8 and 1. Okay, so 8 and 1 are alternate exterior angles. So are 2 and 7, and they're outside. As you can see, they're beyond the parallel lines L and M. Right, so parallel lines L and M are not squashing them anymore. 2 and 7 are outside of these parallel lines, and 1 and 8 are also outside of these two lines L and M. So these are the first two theorems. Now the next one is consecutive interior angles. Now consecutive you might think, well, that kind of looks like they're next to each other. Well, almost. They're not entirely next to each other, but you can think of them as being on the same side of the transversal. Okay, so for example, 4 and 6 are on the same side of the transversal, both inside, right? So 4 and 6 are both inside, and they must be supplementary. Now, of course, this rule applies only when L and M are parallel, okay? So since L and M are parallel, these three theorems so far, they hold true for the fact that they're congruent for the interior, they're congruent for the exterior, for the alternate, and they're supplementary for the consecutive, right? So 4 and 6 are consecutive interior angles. Consecutive because they follow each other, okay? And they're inside, that's why they're called interior, as the alternate interior angles that we've talked about, 3 and 6, for example, they were inside as well, right? Well, here 6 and 4 are both inside as well, right? They don't go beyond the parallel lines L and M. And they are supplementary. So what that means is that together their angle measures will be equal to 180 degrees. 180 degrees is the sum of measure of angle 6 and the measure of angle 4. 180 degrees. Okay. So that you understand. Now, this is not the only pair. This is another pair of consecutive interior angles, right? So 3 and 5, together their angle measures will add up to 180 degrees. And they're both inside, as you can tell. So 3 and 5 are alternate consecutive interior angles, and so are 4 and 6 are also consecutive interior angles. Now, the next one is consecutive exterior angles, okay? Consecutive exterior angles. So here, again, just like in the interior angle case, it will be on the same side of the transversal, right? But here it's going to be both outside. So both outside. So that means it's going to be neither of 4 and 6. It's going to be neither 3 and 5, right? Whichever side you're talking about, it's going to be neither one of these four. It's going to be either one. If it's going to be 2, for example, then the second one will be 8. Okay? So consecutive exterior angles are on the same side, and they must be supplementary, just like in the interior angle case for the consecutive, right? So the consecutive exterior angles are also supplementary. So 8 and 2 are consecutive exterior angles, and they're supplementary. The second pair is 7 and 1. They're exterior consecutive angles, and they are supplementary as well. And notice that they're both outside. Okay, 2 and 8 are outside of the parallel lines, and 1 and 7 are outside of the parallel lines, and they're on the same side of the transversal though, and so is the 2 and 8. All right, the next one is the corresponding angles theorem. The corresponding angles, you can easily locate them by simply matching their corners and positions. What that means is that you take line L, for example. You notice that there's this angle 2. Notice that 2 is above its parallel line L, it's above it, and it's to the right of the transversal, right? So this angle 2 is formed by the transversal and its line L. Now, in the same way, you're going to take the parallel line to line M, which is M, right? M is parallel to L. So in the same way, notice that 6 is above line M, and 6 is to the right of the same transversal, right? So both 2 and 6 are to the right of the same shared transversal, and they're above each respective line, right? 2 is above line L, 6 is above line M. So they are called corresponding angles. And notice that there are 4 such pairs, right? This is not the only pair. There's also 1 and 5. Okay, 1 is to the left of the transversal, and so is the 5. And 5 is above line M, so is the angle 1. It's above line L. The next pair is 3 and 7. That's a corresponding angle pair. 3 is to the left of the transversal, and so is the 7 to the left of the transversal. 7 is below line M. 3 is below line L, right? So they are matching corners and matching positions. And the last pair is 8 and 4. 4 is to the right of the transversal, so is the 8 to the right of the transversal. 4 is below line L. 8 is below line M. Okay? And for this reason, for the fact that they're matching corners and position, and since lines L and M are parallel, the corresponding angles are congruent. Okay, so 8 is congruent. 8 is congruent to 8 is congruent to 4. 6 is congruent to 2. 1 is congruent to 5. And 3 is congruent to 7. Now, the next one is going to be a very easy angle theorem to recognize. Okay, it's going to be a vertical angles theorem. And these two angles will be created by two intersecting lines, and they will be by definition congruent. So, in other words, vertical angles do not really rely on the L and M being parallel. That's why I said in the beginning, most of these theorems are, relying on the fact that L and M are parallel. But in this case, you just need two intersecting lines. Notice that L and M do not intersect. So that's why vertical angles do not depend on them being parallel or not, right? So if they are parallel, vertical angles theorem does not apply. The only way it applies if it has two intersecting lines, right? So two lines must not be parallel, right? If they're not parallel, they will intersect, right? So what I'm talking about is the transversal. As you can see, transversal crosses line M, and also it crosses line L, right? So there will be actually, there will be 4 pairs of vertical angles created as a result of that, right? So the first 2 pairs are here. Notice that the transversal crosses line L, and it creates 2 pairs of vertical angles. And vertical angles, you can think of them as mirror images of each other. So for example, 1 is a mirror image of 4. 1 and 4 are vertical angles, and they're on the opposite sides of the transversal, as you can see in this case. Okay? They will be on the opposite sides of, you can say in general, of intersecting lines. Okay? They will not be on the same side of a line, of any line in question. They will be on different sides of the lines. Right? So as you can see, 4 is on the right side of the transversal, 1 is on the left side. And they're mirror images of each other. And by definition, this is the reason why vertical angles are congruent. Right? So 4 is congruent to 1. The second pair is 3 and 2. As you can see, 3 is congruent to 2. They're mirror images of each other. And they're on different sides of the transversal, or different sides of line L. You can judge by that as well. They're on different sides of these two lines. The remaining 2 pairs of vertical angles are here, right? I said there were in total 4 of them. The remaining 2 are here, right? They're created by the transversal crossing line M. As you can see, 5 and 8 are vertical angles. They are congruent. They're on different sides of the lines of either one of these 2 lines. And the last pair is 6 and 7. 6 and 7 are vertical angles as well. Right? And they're congruent, they're mirror images of each other, they're on different sides of each of these 2 lines that intersect. Okay? And now the last one is linear pair angles. And again, the linear pair, just like the vertical angles, does not depend on the parallelism of L and M. Right? It basically is created by intersections once again. Right? So when you have intersections of a transversal and M, any given line here, as long as you have 2 intersecting lines, you will create 2 adjacent angles that will make a linear pair. So linear pair means that 2 adjacent angles will add up to 180 degrees, right? And that's why by definition they will be supplementary. And adjacent, of course, means that they will be right next to each other. So keep in mind that it's not going to be the same as the consecutive interior angles, because consecutive interior angles 4 and 6, for example, they're not adjacent because they're not separated by a line. Okay, so in this case, 5 and 6 are adjacent. Okay, they're separated by a transversal line here. And notice that they're created by 2 intersecting lines. So 5 and 6 are created by these 2 intersecting lines, the transversal and M. And they're adjacent because they're separated, they're next to each other, they're separated by this line. Whereas in the consecutive interior angles case, nothing was separating them, right? There was no line, right? There was no line. It's just empty space, right? But these 2 are next to each other. 6 and 8 are next to each other. They're adjacent and they're supplementary. Their angle measures is equal to 180 degrees. And you can tell, right? Because this angle plus this angle gives you the straight angle, right? Which is measured by this line, by this straight line. So by definition, this is 180 degrees. 7 and 8 are also adjacent and form a linear pair, so they make a straight angle of 180 degrees, so they're supplementary. 5 and 7 are adjacent, 1 and 3 are adjacent, 3 and 4 are adjacent, 2 and 4 are adjacent, and 1 and 2 are adjacent. So altogether, how many pairs is that? 8 pairs, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 such pairs of linear pair angles. So as you can see, now we reviewed all the angle theorems. There are 7 of them. And now we will apply this knowledge to determine the missing angle measure. Okay? So measure of angle 4 is 108 degrees. So let's talk about measure of angle 4. So this is 4. So we're trying to relate 4 and 5. So 4 and 5. Notice right away that 4 and 5 are on different sides of the transversal. They're not adjacent. So what can you think of? Which angle theorem makes sense here? Notice that on different sides already makes you think of what? It makes you think of alternate, right? The word alternate means different sides, right? Because everything else, consecutive is on the same side, both of these two, right? Corresponding is on the same side, right? Because they will be matching. But they will have matching corners and positions, so they must be on the same side, right? Vertical angles will be on different sides, but they will be mirror images of each other, right? You can think of alternate interior angles, you might say, but these look like they're inner images as well. I mean, yeah, yes, in a way, but the only thing is, it's not as obvious that they're mirror images of each other as it is in the vertical angles case, right? So you can see in the vertical angles case, they share a vertex, right? So 7 and 6 share a vertex. This is the vertex that they share a point, right? Whereas alternate interior angles, 4 and 5, they don't share a vertex, right? There's no point that they share, right? 4 has its own vertex and 5 has its own vertex. It's not the same vertices that they have, 5 and 4, right? So this way you can tell the difference between alternate interior angles and vertical angles, right? So as you can see, opposite sides already makes you think of alternate. You already know it's not going to be vertical angles, and you know it's not going to be linear pair, right? Either, because linear pair is adjacent, right? Adjacent angles making a 180 degree angle altogether. So definitely alternate. Now, which one is it going to be? Exterior or interior? 5 and 4. So notice it's going to be. Notice that it's not going to be outside for it to be exterior, because 4 and 5 are both inside. They're not going beyond respective parallel lines L and M, right? 5 is above line M, 4 is below line L, right? So they're inside. So you know it has to be alternate interior, right? Alternate interior. And you know by definition they're congruent. But even if you forget that it's not exterior, it's interior, you will still probably remember that they must be congruent in both cases, right? Exterior angles are congruent for the alternate, and alternate interior angles are also congruent. So by definition, measure of angle 5 must also be 180 degrees. Now the next one relates angle 8, this one here, with angle 1. So angle 8 and angle 1. As you can see, once again, they look like they're on different sides of the transversal. So you know the word alternate must be there. But this time, it's not inside, it's outside, as you can see, right? They're further out, right? Because 1 is above line L, M is below line M, right? So it has to be alternate exterior angles. And just like the interior angle case, they must be congruent. So 8 and 1 are congruent, so thus measure of angle 1 is also 114 degrees. Next one, measure of angle 5. Measure of angle 5, so we're going to relate 5 and 3, right? So 5 and 3. So as you can see, they're on the same side, right? So these two alternate will not work because they're on the same side and they're inside, right? 3 is below L, 5 is above M. Okay, so they're inside, so you know inside, and they're pretty close to each other. I mean, they're not next to each other like in the linear pair angle case, but they're on the same side and they're pretty close to each other. They don't share any vertex, okay, whereas the linear pair angles, notice that when they're next to each other, they're sharing vertex, right? But 3 and 5, they don't share vertex. That's a way to tell the difference between consecutive interior angles, because they're inside, and the linear pair, right? They don't share the vertex in the consecutive interior angle case. 3 and 5 do not share a vertex. 3 has its own vertex, 5 has its own vertex, right? The linear pair, 5 and 6, they share the same vertex, okay? So 3 and 5 must be consecutive interior angles, right? Because they're inside, okay? So what do we know about consecutive interior? They're supplementary. So the sum of the measures of these two angles, 3 and 5, must be 180 degrees. So that means to find the measure of angle 3, we just subtract the measure of angle 5 from 180, and then we will find the measure of angle 3. So this is going to be 58 degrees. Now measure of angle 3, let's talk about 3 and 2. What is the relation between 3 and 2? That's fairly easy, right? You know they're on different sides of the transversal, and they share the same vertex. So you know that must be what? That must be vertical angles. And notice that they're not adjacent, right? They're not next to each other. 3 and 2 are not next to each other. Like 1 and 3 is next to each other, 1 and 2 is next to each other, but 3 and 2 are not. They're mirror images of each other, and they share the same vertex, okay? But they're mirror images of each other, and they're created by two intersecting lines, which is very close to what the linear pair does, except that vertical angles are not necessarily supplementary, like in the linear pair case, but they're definitely congruent, okay? They're definitely congruent, so you know 3 and 2 are congruent. Okay, and they're on the different sides. They're on the different sides of the intersecting lines. Remember that 3 and 2 are on the different sides, whereas the linear pair angles, they're on the same side, right? 1 and 3 the same side, 3 and 4 on the same side, below line M, L, 2 and 4 both to the right of the transversal, 1 and 2 are above line L, right? But in the vertical angles case, they must be on different sides of the transversal or different sides of this line L, or 1 and 4, right? So if 3 is 78, 2 is also 78 because vertical angles are congruent. Next one, 2 and 6. 2 and 6. As you can see, they're on the same side, so alternate does not work. Consecutive, you might say, why does consecutive not work? Well, consecutive will not work because in the interior and exterior case, they must both be either outside or inside. In this case, look, one of them, 6 is inside, right, because it's above line M, but 2 is outside line L, right? It's not inside like 4 was. Like 4 and 6, you knew were consecutive interior angles, but 6 and 2, they don't relate that way. However, they notice that both of them have the same kind of pattern because 2 is above line L, 6 is above line M, that's parallel to L, and both of them are to the right of the same transversal. So 6 and 2 share the same position relatively, right? They're matching they're matching corners and position, and they are congruent by definition. So if 2 is 69, 6 must also measure 69 degrees. And notice that 2 and 6 are not the only pair of corresponding angles, right? There were also 4 and 8, same position, same corners. 7 and 3, same corners, same position, and 5 and 1. Okay, this is just one of the 4 pairs that we just looked at. Now 7 and 5. So 7 and 5. Notice they're right next to each other. They share the same vertex, and unlike the vertical angles, they're not on different sides of the lines or the transversals, right? 7 and 5 are both to the left of the transversal, both of them, right? So that will help you tell the difference between vertical angles and this 7 and 5 pair, right? This 7 and 5 are not vertical. 7 and 6 would be vertical because they would be on different sides, but 7 and 5 are adjacent, right? They're next to each other, and they by definition are supplementary. So the angle measures, the sum of the angle measures of the 7 and 5 must be 180 degrees. All right, so to find the measure of angle 5, just like in this case, we just subtract the measure of angle 7 from 180, because we know the sum of these two was 180. So to find this measure of angle 5, just subtract 82 from 180. You will get 98 degrees. So that's the angle measure of angle 5. Okay. And by the way, this is not drawn to scale. So don't think, oh, this looks, acute to me. This is just for practice. I know 7 may look acute, but this is not drawn to scale. And every single problem is a unique problem. All right. So whatever you found does not apply to the other. Every single line is a unique question. So whatever angle measure you get, it has nothing to do with the previous angle measure. So some of the angles here repeat. You might say, oh, but it doesn't matter. I'm just asking a unique question per line. So 7 looks acute, and 5 looks like it should be, beyond 90 degrees. And it indeed is 98, right? It's above 90, but it may not be exactly the way it looks. It might be less than what it should be, using your eyes, but don't worry about that. This is not drawn to scale. This is just to enforce your knowledge. So now measure of angle 1 and measure of angle 7. So now let's talk about 1 and 7. So we have 1 and 7. How to tell the difference now? Notice they're on the same side, so alternate will not work. Definitely vertical and linear pair does not work because they're so far away from each other, right? 1 and 7. So the only way, and corresponding will not work either because 1 is above line L, but 7 is below line M, right? So they don't have the same matching positions in the corners, right? So the only thing that you can think of is the consecutive. But consecutive interior doesn't make sense because they both should be inside, right? One of them should be below L and the second one should be above M. But this one is below M and this one is above L. So the only one that makes sense is consecutive in exterior angles, right? On the same side of the transversal, which they are, right? To the left of the transversal, both 1 and 7. And also both outside, which they are, right? 1 is above L, 7 is below M. And also, what's one more thing? Supplementary. Just like the interior angle case for the consecutive, they're both supplementary. So their angle measures add up to 180 degrees. So to find measure of angle 7, just subtract, like in the previous line you've done, 163 degrees from 180 degrees. You will get that way your angle measure. So the angle measure of 7 is 17 degrees. And again, this is not drawn to scale, so don't worry about it. Don't worry that it's 17 degrees looks awfully big. That's not the point of this video. The point of this video is to have you think about how these theorems differentiate between themselves, how to tell the difference, and how to use the most appropriate theorem for any given question like this. Okay, so I hope this was useful. Thank you so much for watching and see you in the next video.